Good evening. I apologize for my absence. I'm double booked, but I wanted to share this video so you all can keep rolling in class, and I'll join you as soon as I can. I've been asked to talk about these study designs, systematic reviews and meta-analysis, and experimental designs. So the objectives for the whole class haven't changed. Our goal is hopefully help you identify and verbalize key differences between studies, identify what to watch out for, what threats are involved with each, in order to help you answer your questions. And I know several of you identified in your initial survey that you might be interested in doing systematic reviews or perhaps meta-analysis. Meta-analysis and systematic reviews are really pooling already existing data. So I'm going to talk about that first, and then I'll talk about the experimental study, which is obviously a primary analysis. Analyzing the available published literature has gotten very popular over the last 15 to 20 years, and there are specific protocols that you need to follow as you go into this. When I was going to school, narrative reviews were very popular, but with the advent of systematic reviews and the Cochrane Review Library generating very specific guidelines and the Center of Evidence-Based Medicine, narrative reviews are still really good. They're a little harder to get published than systematic reviews and meta-analysis. So tonight I'm going to talk about this experimental study design, and I'm going to present one of my research projects incorporating correlational study analysis. So I want to talk about systematic review, and really the procedures and the advantages and disadvantages are basically identical for systematic reviews and meta-analysis. It's important that you remember that the level of studies that you allow to be included in your study, if you go down to level 3 or level 4, that now is the level of your systematic review. Big advantage, especially for students, is that it's a nice way to comprehensively and systematically review the literature. There's not any significant cost to you to perform that other than the amount of time it will take, which it is quite time consuming. It really helps you pull all of the literature together in an organized, systematic manner. Specifically, you're going to have to go through inclusion and exclusion criteria, and as you do that, you'll find out how specific you can be. It does increase the external validity. It's more reliable because it's pooling data together. But there are disadvantages. Often these studies aren't all designed in the same way. They use different outcome measures, especially in our literature. So it's really challenging if you're looking at functional limitations or quality of life assessment to have consistent values, but there's some ways to overcome that. Publication bias is a real problem in doing systematic reviews and meta-analysis, and there are some mechanisms by which you can evaluate that, but unfortunately the bottom line is that it's hard to get a paper published without a significant effect. So that requires you to do some digging into the methods and the results of studies that might have measured what you're interested in but not really focused on that, but they might incorporate that information in their data analysis. So the PICO format is followed, just like it is with a lot of other type of studies. So the goal is to capture the published literature about a very specific question. And it's been my experience is that developing that inclusion-exclusion criteria might take a couple of rounds of literature searching to find what you really can include or what you can really exclude. Sometimes you start broad and you tighten it up, or sometimes you start really too specific because you want to find this ideal information and you can't find anything that matches that information, or you find one study and you really can't do a systematic review on an N of 1. You can do a critical appraisal topic on 1 or 2, but typically with this systematic review you're looking at 7, 8, 9, maybe 5, as I've seen systematic reviews down at the 4, 5 range, but not many, and it's rarely over 15 or 20. There are some that include several, and those are usually lower levels of evidence in the systematic review. The only big difference between the systematic review and the meta-analysis is that a meta-analysis then applies an additional statistical analysis of the available data to create a new data point. And so it takes and pools all of that information from maybe 4 or 5 other studies and says, does this intervention favor a positive outcome, or does it not favor? And it pools that information together. Unfortunately, not all topics lend themselves to meta-analysis, so you'll see a lot more systematic reviews than meta-analysis in some topic areas. And physical therapy and athletic training have a little bit of both. I have no idea how it is for OT and PT, but it's not as much as with the drug studies, where you can see really nice pooled studies where they're using some kind of standardized evaluation form. So this is the process. This is basically a repeat of that process in your book, and this will be more elaborated in our HB 714. We've started helping you with some of this information, but obviously defining a question, defining a search strategy, using your different Boolean phrases, and what I think is really challenging is defining a good inclusion-exclusion and what levels of studies should I include. I might start with more studies and allow 3 or 4s, and then I tighten it up if I see I get enough, but sometimes I don't have any type 1s or level 1 randomized clinical trials, so that is going to minimize my ability to identify a great systematic review randomized clinical trial for a specific exercise intervention or treatment modality. Going through the electronic databases is relatively straightforward. A librarian can help you set up rerunning these same searches over and over again, and certainly there's lots of videos out there. Using the gray literature, which are more the documents, the white papers, information where companies have done stuff, requires more assistance from a librarian, but that can be incorporated. And there's also hand searches, which you typically do if you look through the main journal articles in your area of discipline. So if you're doing aphasia type studies, I'm sure there are specific journals that are the main publication areas. If you're doing ankle instability, there might be 5 or 7 really key journals that you want to hand search through the table of contents, but most of that information should be available electronically. Where I find hand searches somewhat more helpful is sometimes looking at the references of the articles when I'm in the full text review. So just completing screening titles and abstracts for over 15,000 titles and abstracts for a clinical practice guidelines, I can tell you this can take a while. So this is definitely an organized chaos that you have to systematically work through those abstracts at a time, and it takes some significant amount of time, but also a lot of organization to how am I going to include that or not include it. And when in doubt, you include it, and then you have more articles to screen the full text. So again, that inclusion-exclusion criteria is really critical in screening the full text because it sounds good, but then when you actually read it and get into it, you find that that article might not exactly meet your expectations. But this is also where you can search, do some hand search, but if you get into some nice article that gives you some information, they talked about the data you were interested in but didn't publish it, this is sometimes where you have to contact the author and get additional information. And then you're going to set up a table where you extract the relevant information. You might be interested in re-injury rates, you might be interested in balance scores, whatever those specific variables are, and then certainly, you know, the typical things like the number of subjects, the inclusion-exclusion of those subjects, the population that was studied, maybe where the study occurred. In the clinical practice guidelines, we're capturing a lot of different functional outcome measures, so I might have a different column for each of my different functional outcome measures for shoulder instability. And then, depending on if you're doing a systematic review or a meta-analysis, you're going to summarize that data. So there's process where you're going to try to look at all of that data and synthesize that information. When you do a meta-analysis, that's a statistical manipulation where you calculate effect sizes. But if you're just doing a systematic review, then you have to sort of pool together the quality of the level of evidence. And usually when you're extracting data, you're also critically appraising that data and grading the bias or the quality of that study with a standard form. And then obviously you're going to write and publish that. When you go to write it and publish it, and there's a nice procedure that you'll learn in RHB 714 where you have a formal procedure of writing up these protocols called PRISMA. Some of you all might have done that. This is the link to a recent publication in the British Medical Journal. So they've updated it recently in 2015. And it's a 17-item checklist with a lot of additional A's, B's, and C's items, so it's more than 17, but it gives you a checklist, it gives you examples of what they're looking for, and an explanation of what should be in or be incorporated in the manuscript as you write your reviews. So just for an example, as you prepare for your midterm, we're going to give you some abstracts and then you're going to have to identify that. And you can see there's some key words that you want to look for when you talk about that. And the first in the introduction or the purpose should be the PICO. So they're evaluating the effectiveness of different treatments for rotator cuff tears, and their outcome measures are functional limitations and sick leave time. They're going to do a term like a systematic search. We might move the term meta-analysis out and just say an analysis, just to not make it so blatantly obvious. But basically you're looking for something that is a logical, organized analysis. They might include the databases, and in this case they use the headings of the words in the abstract, and then they identify that we identified so many articles and found what worked and what didn't work. So in this study, exercise plus manual therapy was more effective than exercise alone. Ultrasound and extracorporeal shockwave therapy not so effective. And so then they concluded that a lot of these studies don't really use functional limitation or duration of sick leave. So probably this would be a good indication of a gap in the literature that needs to be addressed instead of reporting range of motion and pain levels. So as I said before, meta-analysis will be covered in RHB 714. The big difference is it calculates a statistical analysis, and so you're going to learn a little bit tonight but also later about effect sizes and how you calculate those, and the comprehensive meta-analysis, which is a statistical software, really lets you use the data from your studies and enter that into it so it can create that forest plot and it can calculate a funnel plot for a publication bias. So we're lucky we have that here at the University of Kentucky. That's available to all of you students. But it's not always available to everybody, so that makes it a lot tougher for some individuals. They'll have to find a way to mesh that information together. I think the other big advantage of a meta-analysis is you have like a new data point that pools a lot of numbers together. So if you have 5 studies of 20, now you got one big meta-analysis of 100 subjects. That probably has greater external validity if they're very similar populations, and you have to watch that. So be careful if you have a lot of different populations, old, young, middle age. If they're all young and athletic on both of these studies, then you feel like you have a more homogeneous population, and so your meta-analysis probably is a little more meaningful and stronger. So this is an example of what a forest plot would look like. I'm sure you've probably seen these before, but it basically takes the data from individual studies from Newton and Escamilla and Beringer and looks at what their individual values were from the data we put in. This is a graph from a former doctoral student, and we were looking at if a certain exercise type favors increasing arm or ball velocity. And so these 3 studies are all about plyometric exercises. We had different types of exercise that we did different separate forest plots with. So you can sort of see the confidence intervals are on the horizontal axis of this data, indicating that the individual studies have the point estimate and then the variance. And you can sort of see this square is a little bigger than these other 2 squares, indicating there's probably more subjects in that 3rd study than there were in the other 2. And then what the meta-analysis does is it computes and weighs out these other factors, and it creates this central point. So it's favoring the effective plyometric training, and then this tips of the diamond represent the error. And so if that doesn't cross 0, that means that it's statistically significant, which it was when we do the mathematical calculation, and that plyometric training was favorable to increase ball velocity, measuring those together. And that's sort of what you're doing when you interpret those. If it crosses 0, or for odds ratios or risk ratios, if it crosses 1, then we know it's not statistically significant for improving the effect you were interested in. This is really noisy. I apologize. It was one of the few that I could find that could actually fit on a paper, so this is a meta-analysis comparing the effects of immobilization after a shoulder dislocation. So they had 2 main questions. They wanted to know something about duration and position of immobilization, and does that reduce the risk of recurrent dislocations. So they looked at 2,000 articles. They mainly left it at level 1, level 2 studies, and out of that they identified 6 out of 2,000 that met their criteria for inclusion. So that's a pretty good indication of what happens a lot of times. The data was pooled. They broke it up between below and above 30 years old, and they found that individuals under the age of 30, the rate of recurrence was not really significantly different based on based on the time, 1 week or less. So longer or shorter time periods didn't really matter. The second question that they were looking at was recurrence rates, and so they compared 2 positions, external rotation and internal rotation, and the analysis of the available pooled data found that 25 of 63, or 40% of the patients managed with a internal rotation, the conventional sling, and 25 out of 88 managed in the non-conventional or the external rotation. So it was nearly significantly different. This is certainly a lower recurrence rate, but it wasn't statistically significant. So they concluded that there's no benefit of sling immobilization for a longer period of time. That was clear. The bracing, they sort of hedged, but they bottom line, they said there was not a significant difference with the numbers available, but they did note that there was a difference. So it may provide a clinically important benefit over traditional sling immobilization, which is their interpretation, but the data, the analysis said there's no difference, even though it was close. So it'd be interesting to see what happens if more studies are looking at both internal and external rotations. So what things to watch out for in these populations? You got to make sure that they are consistent and you're good with sticking with your specific inclusion-exclusion criteria. I've gone through this a couple of times, and I've had to revise our inclusion-exclusion criteria to either loosen up our exclusion criteria or inclusion criteria, and sometimes we've had to tighten it back down because we had just too many studies. The plyometric or the ball velocity study, we were able to tighten down and get it to level 1 and level 2 studies only. Publication bias is tough to analyze, but I think the two things that I would recommend, if you're doing comprehensive meta-analysis and you're doing a meta-analysis, it helps you do a mathematical calculation, but that's not as common. So what I would tell you is you want to look for studies that are measuring stuff in your same topic, but they might talk about articles, or they might talk about findings that aren't directly related to what you're looking for, but they might have measured those anyways and just didn't focus on that, because it's hard to get it published when it's not significant. So really look carefully when you're doing your full text review in the methods and see if they did happen to measure what you're interested in addition to what they focused the abstract on, or what they focused the other information on. So that way you can get good and bad results, and that minimizes your publication. Thanks for your time, and hopefully I'm there by now and can do the rest of the presentation. If not, you'll have another extra video recording.